Welcome to Building Plan Generator, a powerful tool to create an entire plan of the building. The sole reason behind this application is to ease the user instead of toiling to draw it from scratch. So let's get started right from the top. To make a plan, the basic building dimensions of width and length is to be first provided. This application requires all its input in millimeters. So here, I'll edit the width to be around 30,000 mm and the length to be around 60,000 mm out to out of steel. Now we'll move on to the next section, which is divided into several subsections. The first one is width and length parameters, which are for the interior frames. And on either side, we do have LEW, left-hand wall, and REW, right-hand wall, for the exterior frames. Right next to the width and length dimensions, you might have noticed the auto option. So once we enter the preliminary dimensions, we can use this option wherein all subsections below it gets automatically filled. And an alternative to this working mode is that all these subsections can also be edited manually. So let's see how that works. Under width parameters, as a first point, the column spacing is provided to sort of the framing type. This can either be a clear span, multi-span with n interior columns, or a multi-gable building. For a clear span building, the column spacing is excluding the center of steel column to out of steel distance. So let me take that value to be around 400 mm. On the other end, you can see this automatically changes to 350 mm. So for this case, if I need both these values to be equal, I'll have to change the column spacing to be around 29,200 mm. Below this, you could see the corresponding grid marks for the main frame column, F and B. Now, to create a multi-span building, the width module has to be provided. So for instance, multi-span with one interior column, I'm providing the module to be around 14,600 and 14,600 mm. So here, I can use either a space, comma, semicolon, or a plus sign. And you can see correspondingly, the grid mark varies right below as G, E, and B. Next, the ridge distance. This denotes the slope of the building. For a dual slope building, which may or may not be symmetrical, the ridge distance has to be provided from the out of steel. So for here, I'm providing it to be around 15,000 mm. In case of a monoslope building, I have two options. Either I can give this value to be 0 or the entire building width, that is 30,000 mm. The only difference in here is that the direction of the slope varies. Following this, the valley distance. This is applicable for multi-gable buildings only, wherein the distance indicates the location of the valley gutter from the out of steel. As the multi-gable buildings have two ridges, we need to provide those two ridge distances. So let me first alter that distance to be around 7,500 mm, which is the location of the first ridge, and the next distance should be entered with reference to the first one. So I'll have it around 15,000 mm. So now, if the valley gutter is to be placed in the center of the building, it is going to be around 15,000 mm from the out of steel. The next being the column size, which facilitates the sizing of the mainframe columns. The number of column sizes to be provided depends on the column spacing. The last one under the width parameters being wall bracing. We use different notations here to indicate various kinds of bracings. DB for diagonal bracing, PB for portal bracing, PD for portal and above diagonal bracing, and NB for no bracing. So next, we'll move on to the second subsection, which is length parameters. The first one under this being base spacing, which is exactly similar to the column spacing under width parameters, but along the longitudinal direction. So maybe the center to out dimension along the length of the building, I'll change to 375 mm. And the base spacing is completely as per user requirement. Herein, let me make this to 7,125 plus 6 at 7,500 plus 7,125. And the other end also, I have the value to be 375 mm. The grid marks along the length correspondingly changes, and this can be manually altered as well. Following this, the brace space. This identifies the location of the bracings. That is, we have here 2-3 and 7-8, which means the bracings are to be provided between the grids 2 and 3, 7 and 8. The bracing location can be changed as well. So let me change this to the first bay, that is 1-2. Next one is canopy. We'll have a look over it a little bit later. Now, you might have noticed certain checkboxes provided for certain parameters alone. So for example, if I untick for the checkboxes under width parameter, and I try to change the column spacing to 14,600 space 14,600 mm, you can see that there isn't any change. Now, let me take the checkboxes and make the changes again. 14,600 space 14,600 mm. The grid mark, column size, and wall bracing gets automatically modified. This does with respect to the column spacing. The grid marks under the length parameters depends on the base spacing. In case of any manual mistakes done by the user while editing the parameters, for example, instead of providing two wall bracings, I'm adding an additional one. Immediately, Building Plan Gen intimates the user with an error sign. So once we have provided all basic information and made sure there isn't any error, the generate option converts the input to DWT script format, which gets imported to ZWCAD to create the building plan in .dwt template using the drawing parameters provided in the top right corner. We have generated here a building plan for a clear span building. The width and length is as entered, 30,000 and 60,000 mm out to out of steel. The ridge is at the center, and we have two bracings in the first and the penultimate bay, along with diagonal wall bracings as mentioned. You can see the center to out distances and column spacings along the lateral and longitudinal direction. The left end wall framing type is rigid frame with wind columns, and we have replicated it the same for the right end wall. Along the end walls, we have canopies for 1500 mm. The respective grid lines and its dimensions are all clearly marked. So similarly, I've generated here a few other plans. First one is multi-span with one interior column. The column spacing along the lateral direction is 14,600 and 14,600 mm. And I've also made the left end wall framing type to be rigid frame and the right end wall to be post and beam. And you can also see an additional wall bracing at the interior column. The second one is multi-gable building. I have two ridges here at 7,500 mm and 15,000 mm. And a valley gutter is placed at 15,000 mm from out of steel. The last two are the monoslope buildings. When I have the ridge distance as 0, the roof slopes towards the far side wall. And on contrary, when I have the ridge distance equal to the width of the building, that is 30,000 mm, the roof slopes towards the near side wall. In case building has accessories like canopy, Building Gen provides an easy access for any location. So for example, I'm taking here for the required width, a corner canopy between left end wall and far side wall, and also along the near side wall for the full length. In certain cases, when the canopy width exceeds or is equal to 3000 mm, canopy bracings are added at required location. We do have an additional facility to save the input parameters in .txt format, which can be availed in near future. So for this, we have a save as and a save option, and also an autosave option, which automatically stores the input in the respective file with each and every click of a generate option. With the open file option, we can use this saved text document. So this is all you need to know about Building Plan Gen. Thank you.